Hey, it's Bob Hughes with JD Squared. This is not a sales video. What we want to do is let our customers know the status of the machines and the changes that we made. Now what you're looking right here is the first 6, 7 machines that are getting ready to go out the door. Hopefully by this Friday we'll have them done. In fact, this is Mike Furick's machine, the god of TIG welding. And you'll pretty much notice a stainless steel table on it. This was actually Mike's idea. After he saw our other videos, he said, can you put a stainless steel table on it? So it took a couple weeks. Now all of our water jet tables are stainless steel, and we've got Mike to thank for that idea. Anyway, these are the machines being built. And what we've got, if you come this way right here, we've got, this is Luke Wilson's machine out of Kentucky. It's a 5x10 machine. And what we're going to do is we're going to fire the thing up, and we're going to start drawing the Mayan calendar. We obviously can't put a plasma unit on it yet because he's got it at his facility. And we like the Mayan calendar because it's a very complicated program. It's got a lot of moves in it. It's very complicated. And we're going to be drawing that at 600 inches per minute using a dry erase marker. Well, let's come this way here. We have relocated since the last video. This will be our permanent setup. We've relocated the control box off the gantry, put it on the side of the machine. That's allowed us to have a reliable 1250 inches per minute rapids without stressing the motor much over 90% or 85%. We've improved the breakaway system right now. This is obviously the magnetic torque system. These are all standard. Luke, I hope you like that. And what we're going to do here, let's go ahead and I'll show you the 1250 inch per minute rapids, roughly what that's going to look like in real life. So that's moving on that axis there, the y-axis. We get that right there. Now what we're going to do now is we're going to move, and we're going to home the machine. So we'll move it to the rear. Before you can run a program, you need to home them all the time. Okay, we hit the home all button, and you'll see her lifting up. She's homing. Okay, at this point, what we're going to do is we're going to hit the run button. She's going to zip up here, and she's going to start drawing this calendar out for us. So let's hit the play button. Okay, here she comes. Running very, very smooth. We're very happy with the way she's running. Okay, now, while this is drawing, that's 600 inches a minute, by the way. Let's walk over and let's just take a look at some of the things that we have changed. We've gone to a single high-speed cable carrier. This is since the last video, so all the customers, this is what they'll be getting. Let's walk over here, Demi. The stainless steel table. Show you a couple features, Luke and Mike and everybody else out there. What we've done is I was really fanatical about being able to level the slats and everything. So what I developed is this cam system here so that regardless of the tape, the table height, the level of that, you can level out your slats right there, and you got these little snail cams. All stainless steel hardware in there. Another thing, another Mike Furick suggestion was, could we figure out some way to put some guards on the side of the machine to keep it from splashing over the side? So what I did is I added the holes all the way around the frame. Now what these allow us to do too is you can put jigs on it if you want to make the same part over and over and over. You could have something, for instance, that bolts here and may hold the little part that you do some trim cutting on or whatever. But also, if you simply bend some pieces of metal, put some holes in it, put a weld a bolt in or whatever, you can now just use it as studs, drop down your guards, and help prevent the splashing. Obviously, when you home the machine, you better take the guards off the back or you're going to run into it. Other changes we made, we've gone to a bolt-together table. Let's come over here and I'll show you how we did that. This sounds like a sales video, guys, but it's really not. I'm just showing you guys what we've been working on. This is our new table right here. When we went to the stainless steel table, we can't make this thing out of all stainless. And I had mentioned in my last video, I don't like bolt-together tables, and I still don't. Well, when I was referring to bolt-together tables, you know the ones I'm talking about, the ones that are made with the 80-20 tubing. They're basically the toys. So what we did here is we had to go to bolt-together, but we made it with 3/16 inch steel, 12mm bolts, and if you look up here in this area, when we powder coat it, we've left this bare. So that once you're assembling your machine, if you want to, you can run a couple tack welds right there. Now you have a full welded structure. Thing's built like a tank, just like it always has been. But this will allow us to ship it easier to Europe and Canada and stuff like that. Let's walk right here. Let me give him a screwdriver. We'll open up the control panel. All right, this is really cool stuff right here. We're really proud of this. This is what my son does right here. And what we're looking at Come over here, Demi, if you don't mind. That's the new control panel. She should run anywhere in the world. The power supplies will run from 190 to 250. This is the computer that we manufacture here. If you come to our facility, you'll actually see a tour of where we have the pick and place robots and everything we make it. That's the torch height control. You can see it blinking active or inactive. And it's really cool because it'll run with just about any torch that we know of in the world. And if we have an issue with this, you call us on the phone, and if it's the torch height controls problem, we're going to apologize to you and get you going again. We're not going to play this game where we charge you $1,000 every 6 months for a new torch height control because yours burns out. If you look at all the Eaton components, we have the on-offs by Eaton. All the wires are labeled with the schematics and everything. The special attention has been made to grounding of the machine. And let's close this up. And if you want, Demi, come over here and we will. This is on vibration isolators. That's why she's wiggling it right there. Take the shock off that. If you come over here, that's the grounding bar set up right there. And what my son has done, he's designed a machine where all the critical grounds and everything is going to go to the grounding bar front and back. And the idea being is to get rid of high frequency noise, we want everything with central ground. The wires in this machine are extremely expensive. They're made by a German company. Their main goal is high flexibility, high speed machining, and high frequency noise rejection. We've used those. The chain guard, we switched to a company called Igus out of Germany also, and these are high speed chain guards. Now obviously 1,250 inches a minute. I don't know if that qualifies for ultra high speed, but what the hell, man, let's put the good stuff on the machine, make it last. Anyway, that's the computer stand right there. We'll show you some other stuff about how to operate the actual GUI in a later video. We don't have time, this is just a quickie. But you can see it, listen to it right here, just listen to the noise, or lack of noise I might say. And you can hear it moving up and down, and that's 600 inches a minute right there. When she gets done drawing this bad boy, takes about 10 or 15 minutes, she'll be done. Okay, we're getting near the end of the drawing right now, and you see it zip on around right here in a couple seconds. Give you a good idea of what 600 inches a minute looks like. That's 1250, of course, coming across there. This program, by the way, is 4 megabytes, 210,307 lines of code. That's why we ran it, because it really, really stresses the look-ahead features of the controller. It uses a lot, memory, a lot of memory, stuff like that. And that's 600 inches a minute right there. And voila! We now have ourselves a Mayan calendar. Let me bump her on the back here. And there you go, that's the Mayan calendar. Thanks for watching, and Luke, Mike, everybody out there who's ordered them, I really appreciate it, and we're working hard to make you guys happy customers.